All right, so good evening, everyone, and welcome to the Tech Confab podcast. My name is Joe Budu. I'm going to be your host, and I'll be engaging in insightful conversations with other experts in the tech industry on trending topics in science, technology, innovation, artificial intelligence, and more. And today I have a special guest I'll be talking to. He goes by the name Engineer Dr. Henry Nunoo-Mensah, and he's a lecturer at the Kwame Nkrumah University of Science and Technology. So I'll be discussing the topic locally engineered ventilators. We all know how important ventilators are in this season for critical healthcare in our hospitals, and he is one of the top guys that's pioneering this movement in Ghana. And obviously, I'd want to interact with my viewers as well. So this is going to be interactive. I'll allow obviously for your comments, contributions, and questions to come in as the stream goes on. Um, yeah, so make sure you share the link with your friends and family. Let your friends and family also join in. We'll be starting really, really soon. So you can share this on Facebook. If you are watching me live on Facebook, you can just share this live video so all your friends can see it. If you're watching on YouTube, just share the link. You can tweet about it. We are also live on Periscope as well. So wherever you are, just share the link with your friends and let them also join in. We'll be starting in a little bit. I would also want to know those that are watching me live right now. So if you can just type in the comment section, your name and where you're viewing from, I would really want to see who's watching me today. So keep your comments coming in. Let's keep this interactive, and we'll be starting the show really, really soon. So of course, if you're sharing the hashtag is Tech Confab, so you can tweet about it. Let your friends know about the show. You can share it on WhatsApp as well. Share the link on your status. Share it on your groups. Share it on your broadcast list. Share it to all your contacts. Yes, this is the Tech Confab podcast, and it promises to be an exciting one today. Very interesting topic. Yes, Martin, welcome to the show. Martin, you're watching from YouTube. Good to see you. Once again, the topic is on locally engineered ventilators. We're starting in a moment. My guest is on the line, Engineer Dr. Henry Nunoo-Mensah from KNUST Ghana. Yeah. Natasha, welcome. Welcome to the stream. You're watching from Facebook. Nice one. We'll be starting in a little bit. Just let me know where you're coming from, where you're viewing us from, and we'll be starting shortly. We are live. All right, viewers. So we have um, Dr. Engineer Henry Nunoo-Mensah. Um, yes, like I said before, he's a lecturer at the Kwame Nkrumah University of Science and Technology. He's been teaching computer engineering since 2016, and he has written a number of papers. And he's basically a pioneer when it comes to telecom, computer engineering, and even AI. I understand. So, Henry, welcome to the podcast.
Thank you. Thank you very much.
Yes, Henry is also my good friend. We are actually classmates back in
Uh,
tech. I was
yeah,
doing electrical engineering, he did computer, so we had a lot of common courses.
uh,
Yes, so we had a lot of fun times back on campus. And I'm sure quite a number of us also might know him as well. I think one of your students, Osei Tutu, is also watching. He
so,
was lamenting about you just yesterday. Anyway, yeah, so welcome, Derek Boyson. Welcome, Osei Tutu Apia to the stream. Yes, and welcome, Henry, as well. Welcome to the show. How's it going?
yeah, everything is fine. Everything is fine.
Wonderful, wonderful. All right, so we have our viewers watching from Facebook, from YouTube, and on Periscope as well. So Henry, can you just tell us a little bit about yourself? What have you been up to this, past years? A little bit about the research work you've been doing, what you've been studying, and what you've been teaching as well.
Okay, so uh, once again, thanks for having me on your show, right?
Yeah.
Um, yes, for some time now, I've been doing some research when it comes to wireless sensor networks, like security in wireless sensor networks.
Okay.
Yeah, and I also do stuff in intelligent agents. So currently we are looking at AI for D and all that, right? So and with the wireless sensor stuff, I'm doing more of privacy stuff, trust management and all that.
Okay.
Internet, so you can relate that to Internet of Things too. So that's what I've been doing for some time. Yeah.
I see. Interestingly, I'm also doing a master's in artificial intelligence. Like, why is everybody trying to go into AI now?
So
Henry,
I
why?
think AI is the future, you know.
Is it?
Yeah,
Yeah,
so
of course.
yeah. So I think even with this COVID issue,
Yeah,
right, you've seen how oil is suffering. Mm?
exactly.
So data is now the new gold, right?
Yes,
Yeah.
yes.
So if you follow that path, I'm sure you are going to stay relevant for a very long time. So
That's really true. That's really true. And I mean, I've been sharing. I mean, we've been discussing on my past shows about the importance of us upgrading our skill set and the importance of AI and all that. And basically, whatever industry you're in, whether you're in marketing, you're in business, you're in finance, you still need to upgrade yourself when it comes to AI because it's going to be essential in the near future.
yeah,
Yes. So those of us that do not know. Um, Dr. Henry is part of the team that recently outdoored the locally um, engineered.
2017, right? I think it's supposed to be a collaboration between Michigan Technological University in the US and
Yeah.
Kwame Nkrumah University of Science and Technology in Ghana. Right. So on the side of Ghana, KNST, in 2017, we had to put some group of students together. Right. So a group of students were put together, right, and assigned the project. And at that time, the project was supposed to the students were supposed to design a system, right, that is similar to the system that our US counterparts had, right? So the students were able to do that, and the students were supervised by one of the lecturers we have in our department, that's Dr. Ahmed Yakub, right? So if I can even mention the names of those students who actually started working on that project, I think it will be nice. There were Akwesi Dakwa Akwabwa, right? Josephine Owusu Echang, Aisha Tiwa Ahmed, Isaac Kumi Kodia, Stephen Kwabena Asante, and Efua Buachua Apia. So these 6 students actually started working on that project, right? So after their final year, they did quite a lot, right? But what happened was that they used Arduino boards, breadboards, variable boards, and all that. It's a student project, and right? So the desire to us in continue the project was there, but we had some issues with funding and all that. So recently, this COVID issue, right, came up, and we decided to take the issue up again, right, and look at the ventilator that was started by the student and see how we could put it together in a very good shape, right? So my boss, that's Professor Boateng, put together a team of lectures to look at that, yes, and we re-looked at the circuitry, we redesigned it, and got a PCB to control the pneumatics, the mechanical aspects of that, right? So that's what led to what you're seeing behind me right now.
So it's very, very critical that we as Ghanaians or we as Africans are able to produce our own equipment to handle the situation, because the Europeans or the other countries, everybody is basically struggling for the same resource. And so once we come and join them, who's going to give you their ventilator? So I think it's very critical that countries like Ghana and other African countries are able to innovate and produce their own equipment. So I think it's a really, really big plus um, on our side. Yeah. So Henry, what's the way forward? When can we see some mass production? Like, what stage are we in the development process?
Oh, okay. So I think now we are partnering with I think the Ghana Health Service, right, and we are working with their engineering unit, the engineering department, right. So together we are looking at specifications, right, because they are the users. It's like being a software engineer. You have to
Okay.
work with user requirements and all that, right? So we are working with them to fine tune stuff and all that, right? And
Yeah.
we also, I think, drawn the attention of Standards Authority, the Ghana Standards Authority, right? And they have also agreed that as we work with GHS to fine tune some of the parameters there, right? We can also start some calibrations or standardizations in parallel. You get it? So that
Yeah.
we don't have to finish with this. So all these things are supposed to help us to get these things to market early. You
Okay.
get it? Yeah. And the team in particular, there's a feature that we want to add to it. All right. So once we add that to it, yes, we would now be able to actually eliminate the health professional who might have to come to the device and set the device based on
Okay.
some patient's vitals and all that, right? Yeah.
Yeah.
So once we're able to integrate those things in there, we might be able to eliminate the health professional. Yeah, and we've started meeting on that, right? So we are still working on pushing things out. But worst case, the ventilators you have it now,
Yeah.
right? Yes, is from the meeting we had, right?
Mm-hmm.
The press briefing that we had, we were estimating completion to be about 75%. You know that, but
Okay.
the Ghana Health Service professional who inspected the ventilator the day before, I just came in and said no. What he saw is about 80% complete. You get it? So it means that as we have very little to do to make sure that it's up to um, a level where we can start looking for some validation and all that. Yes, so that's
Okay. All
I know
right.
it
So
might not take long.
All right. Yeah. So viewers, you can keep your comments coming in. If you have any questions, you can just put them in the comment section below, and we'll address them when the time comes. Or you can just comment of what you think of the ventilators, whether it's a good innovation, whether it's a good step that we've taken as technocrats, and just keep the comments flowing. Right. I would want to hear from you as well. What your views are on this. So keep the comments coming in. So Henry, I want to ask, on the ventilators, right? I actually saw a friend of mine shared basically the documents that had this particular project, a particular group, and my concerns was, some of the things that you already spoken about in terms of quality control and standardization, because this is a life support system, so you can't just put any mechanical system on life like as a life support. And so I want you to just talk about how ventilators work and what mechanisms you have to put in to have a ventilator that's able to sustain life and not rather hurt the patients. And also, recently we heard that I think that was Academic City University College. They were able to also produce a prototype. I think that was about a week ago. So how does this one differ from that one? And basically, how do ventilators work, and what mechanisms do you have to put in place to ensure that you are providing essential life support?
Okay, so simply put, ventilators are supposed to help patients that find difficulty in breathing, right? So it's supposed to help them to breathe. So it's a device that pumps in a mixture of oxygen and air to the lungs, right? And also help with the exhalation process, right? So basically that's that, right? So you need to have a mechanism in there to be able to push the air to the patient, and also what help the patient to push the carbon dioxide out. Right? So basically that's that. But you can't just push any amount of oxygen to the patient, right? So what you need to do is that one very important thing is the control aspect of it. The mechanical
Right.
aspect is mechanical, right? So the control aspect is where the electrical engineers or the electronic engineers come in, right? So we need to know the exact, make sure that whatever settings, whatever things, pressure we are supplying to um, the patient, right, is
Yeah.
as is. You get it? So when you talk about these things, calibrations come in, right? We need to calibrate them, right? Yeah. So with even with the system that we have now, we are still calibrating. We are still
Okay.
calibrating. We are still calibrating. So calibration is very very important because it's something that you are going to use on a human being.
Yeah.
You get it? Yes. So you have to make sure that you cross your T's and dot your I.
Precisely.
You get it? Aha, yes. So but with the academic city ventilators that they've done, the final thing they have, I only saw what they posted. I
Yeah.
think they video and stuff. Yes, but at that stage they didn't have the controls in there. I don't know if they have the
Yes.
controls.
Yeah. From what I saw, City FM did a news article on them. From what I saw, they haven't yet put in the controls, and there's just a regular, mechanism that's doing the pumping
Yeah, so I think they even have an ambu bag um, system,
prototype.
right?
Yeah.
They have an ambu bag system, and these ambu bag systems they have their own limitations. You get it, and these are systems that are supposed to be used during emergencies, right? Unlike these, like the ventilator, the prototype that we have here, which are supposed to be used for a longer period, because ideally they are life support systems. And for life support systems, they can be on for a year, 2, 3, 4, 5.
Yeah.
You get it. So you need to
You need a
uh,
very robust
yes,
system, right?
a very robust system, right? Choose so when it comes to your component selections and all those stuff, these things are very very important, right? Because some of the modifications that we had to do, right, when we took on the earlier prototype done by the students, right, was to change some of these components, right, which was causing the system to overheat, right? Yeah. So now the heat dissipation levels gone down and all those stuff gone down. All right. So the system, the longest we've tried, the longest we've tried putting the system on will be about, I think one time we put it on for about 5 hours or something. Yeah,
I
so it
see.
was on, just working. Yes, and we didn't experience any heating up and all that. Yeah, so you see, these things are stuff that as engineers we need to look out for when we are designing. Right? Yeah,
Yeah,
so that
yeah,
that's
yeah.
that.
So I think we have a few questions just on that particular topic. Yeah.
Okay.
So Sledge Rumpon is asking. So he's saying that Henry, is the ventilator built for the international standard? And Deladem Kumoji is also asking why that kind of radio in a box design.
Uh,
I think to answer that, it's a prototype, right? So probably the
yeah, it's a
finished
prototype.
product
Yeah,
would
yeah,
have
yeah,
a better case than
yeah,
this.
yeah.
But I think the question on the international standards, that's a good question to answer.
Okay, so yes, when it comes to the standards, right? Yes, we are trying as much as possible to adhere to standards, and with these ones, we have basic principles. Right? We have the basic principles that ventilators operate on, and these basic principles, we've those are the ones that we've taken into consideration to come up with these ventilators.
Yeah.
You get it? Yeah. So the underlying principle works, everything works. So the together with some lectures on the biomedical program, right, we've been able to, in a way, fine tune some of the settings, right, the settings that we need to set, right. And one thing about this too is that with ventilators, you don't have preset stuff, right?
Okay.
You set or you make the settings based on the patient that you have.
Precisely.
Right. So, for instance, if I have, there are some inputs to the system. For instance, your PIP, your PEEP. So that the PIP, that's the PIP, the peak inspiration pressure, right?
Mm-hmm.
Yes. And you also have the positive end expiration pressure. That's the PEEP, right? Before you have the breaths per minute. All these things you set are not fixed. So
Yes.
depending on the patient, so your parameters that will be given to you will not be the same as that. So our work will be to make sure that if we set a PIP of, let's say, 25 centimeter water, right, constantly the system is supplying
That amount.
a PIP of, yeah,
Yes.
25 centimeter water. All right, so for that one, we have done that. You get it? Yes. For that one, we
Great.
have done that. Yes. And I'm sure when we get this to standards authority, right? Yes, we should be doing more calibrations from their end and all that. Personally, the team is still doing calibrations, as I said, right? Yes, of the components that we have in there and all some other stuff that we need to look at, right? But when we take it to the standards authority, they also do their checks to make sure that it conforms. You get it?
Wonderful.
So
Wonderful.
yeah, yeah, we are trying to adhere to best practices. So
That's good.
that's
Okay, another question we have here. So Bruce Sam AB is watching from Facebook. So he says, good innovation. Do we have plans for other critical life-saving machines? For example, defibrillators and EKG machines. I think EKG is electrocardiogram machine,
yes, yes.
right? Yeah. So what do you have to say on that? Do we have plans for other life-saving reasons? Because I believe that these machines are also in need if there should be um, the case for that. But I think
Yes.
even right now there is the need in our health systems for these critical life support systems because truth be told, we don't have the resources that other countries have in Europe and other countries. So um, what do you have to say about this question?
Okay, so for the ECG aspect, yes, it's something that came up when we met the Ghana Health Service engineers, right? So they were recommending that we add the ECG, then the SpO2, which looks at the oxygen content in the blood, like the blood oxygen and all that, right? Because of the monitoring nature of the ventilator, I told you it's a life support system,
Yes.
right? So aside helping the patient to breathe, you should also help monitor some vitals. You get it?
Yeah.
So those were things that the engineers from Ghana Health Service um, um, suggested, like recommended, which we've taken into considerations. These things are not too difficult to integrate. We've actually had a meeting to look at that, and we can easily do that. Yes. So doing that is one thing, but making sure that it's working as is. That is
Yeah.
where the ingenuity has to come in. You get it?
Yeah.
So that's that.
Yeah. Another
But
thing that's okay. All right.
yeah,
Yeah. Another thing that I wanted to just point out, this is it's a life-saving device, and I did a little bit of background research on this topic, and basically, if you don't put in the right amount, so we have the lungs system, right? If
yeah,
the lungs are able to support itself, right? You then should be able to reduce when it gets to that stage where the lungs are able to support itself. Then I think you have to start reducing the effect of the ventilator. It basically has to monitor the lungs of the patient and adjust accordingly. So you don't just by force, because I guess you can get some lung collapse. The doctors on the chat should be able to help me here, but I think if you
yeah,
just by force, force air into the lungs, you could cause a collapse of the lungs altogether.
yeah. So I think let me just chip this in,
All
right?
right.
Yeah. So one disadvantage of using those BVM stuff is aside fatigue and all that, right? You checking the amount of pressure that you be exerting on
Exerted
the
on the
patient.
patient, right?
Get it? Yes. So those are certain things. But with the device we have now, with the prototype we have now, right?
Yeah.
So there's a control system, a feedback system in there that makes use of some sensors and all that. Right. So what
Nice.
happens is that you are monitoring the pressure in that you have in the duct, right? The
Okay.
duct to the patient. So what you do is that you check, I'm looking for 25 centimeter water. Okay, if the patient tries to breathe, right, there's a possibility of the pressure going up, right? So
Yeah.
once the
Yeah.
pressure goes up, right, it will mean that you would have to compensate for that error. Right,
Oh,
so
okay. Okay.
there's a whole control system in there, right, to help you to work on the pressure, to adjust it so that the pressure in the duct will still remain the 25 centimeter water. You get it? So
Yes.
that is
Yes.
something that yes, the system does using that pressure feedback stuff
Okay.
system. Yeah.
Great. We have the last question here for now. If you have some more questions, you can just put them in the comment section below, and we'll probably treat them at the end of the stream. So I don't know who front office is, but front office is asking, what would you need to have a mass production? Would you be buying components from China to produce in large quantities? He's watching from YouTube. What would
Uh,
we need for mass production?
yes, we need money. We need
Of
money.
course.
We need money. Yeah, and you know that one thing about R&D is I was discussing this with some guy some time back, right? And I was saying that you can even spend about $1 million
Yeah.
to produce a device that you sell on the market for one Ghana cedi. One Ghana cedi. Right. So for R&D, it's very like fund intensive. You need to push money in because for this device that we are talking about, right? You would have to sample components. You'd have to sample parts. Then
Okay.
before you can know the right parts that you have to use. So you don't just buy one type of a particular part and think that that is all. No, you get it. So there are so many variables in there that we are trying to work with. right? And with respect to the components, right?
Yeah.
Yes, we would have to go order, right? So wherever we can get orders from, with this one, we were able to order some parts from China and from the US and all that. So yeah, so that's that.
One.
We can't say that we will not order for components. We need components to do that.
Sure, sure, sure. That's great. Now, I'd want us to shift the discussion a little bit from this particular development and move a little bit to Africa, right? So now we've
Yeah,
seen specifically in Senegal, right? We've seen some great innovation going on in Senegal, where they are providing $1 testing kits and also producing $60 ventilators. And I think the ventilators were 3D printed, and actually Senegal has the largest recovery rates in the whole of Africa and third in the entire world. So you
yeah,
can see how innovation when it comes to science and tech is actually bringing great impact and bringing a great change in fighting this global pandemic. What are your comments on this? I think it's a really great innovation
yeah.
from Senegal.
I think, yeah, for Senegal, we need to commend them. They are doing great. Yes, they're working very hard. Yes, and I think I was trying to have a look at the ventilator that they did
Yeah.
ideas, but I think the news item on that didn't really show much
Yeah,
of
I
it.
know that
Yes.
a couple of people, right? A couple of companies are using so MIT open sourced one like a ventilator design. So and basically you just need to 3D print and you can modify it to your use case or your scenario. But um, I think I think that should be also an option, right? We should be able to also use the power of 3D printing to mass produce some of these devices, and also make use of because ventilators are is not a new invention. You don't necessarily have to invent your own new ventilator. You just need to know how to produce it, like what you need to produce, and then you start producing. Um,
Yeah.
so I think they are using the power of 3D printing to scale up in terms of producing these machines. So
Yeah. So I think for the 3D printers, right? Yeah.
yeah,
So the fact that they might be printing parts
yes,
like casing, some tubings and
yeah,
stuff.
precisely.
You get, yeah. So it's not the actual like the core.
Electronics, yeah, of course, the electronics
You get,
are not
yes.
3D
And
printed.
there's actually a whole pneumatic system in there. That one you can't 3D print. You get it. So maybe with a case, I don't know. There was a video flying on this project that we did. That
Okay,
moving forward, we're looking at 3D printing some parts and all that to actually make the prototype that we have now look more presentable, and also in a way design the casing in such a way that would reduce the noise, right?
okay.
Because with this one we weren't paying too much attention on let's
Those
say
nitty-gritties like the
yeah,
noise and
like the noise, right? Yeah,
yeah,
so you find out that the pumps and all those stuff in them make a lot of noise. We've tried to minimize it, but it's not the best, right? Yeah,
all
so
right,
with a better casing, we can eliminate the noise. You have a ventilator sitting next to you, and you might not even realize it's there. You get it?
nice.
Yeah. So that is when the 3D printing can come in. Right? We can come up with casing and all those stuff there. But for the actual components and all those stuff, that is also in a different dimension. Right? And with the component selection and all those things, as I stated earlier, right? That is where the ingenuity comes in. You see,
Okay,
you have to be smart when it comes to those selections. Because if I say that, okay, use a resistor for this side, right? Or what kind of, or maybe use a relay, right? You
mm-hmm.
might there's there can be another device or another component that can work just as a relay. You know,
Precisely,
relays make noise. They have a clicking
yeah,
effect. Yeah, yeah. So if I can have another component, something like a FET or something, right, which would not make too much noise, right?
Yeah.
I can achieve the relay feature with my FET or something. You get it? Yeah.
Yeah.
So that is where the smartness comes in, or the yeah, the ingenuity comes in. Yeah.
Okay.
So the differentiates the one engineer from the other. So that's
Well, it looks like only the engineers are commenting in the chat. I think we need to step it down a little bit for the socio people to also
okay.
understand.
Okay, fine. Sorry. Yeah.
Oh, yeah, but let's move on, to something more relatable. How generally do you think we can improve, such innovations in Ghana? Because we actually need it, and we don't see too much of that. So how can
Mm.
we improve such innovation? What is preventing us from doing more of that and all?
Mm.
And yeah,
Yeah, I think funding is an issue. Funding is seriously an issue. Right, and it will surprise you to know that most of the funding that comes into the country comes from outside. You get it? And
okay,
when someone is funding you or giving you money for something, it means that he's giving you because of what he would get from that.
I see.
Get it? Yeah. So
Yeah, of
you
course.
realize
I
that
mean, it's natural. Nobody will give
yeah,
you free money. It's nothing like a
yes,
free lunch.
yes, that's exactly. So you realize that most of the deliverables from the research that we undertake in this country, like, they do not really end up here. They will have to go because there's
The
some
person the
funding.
person that funded it is not here,
Yeah,
so
there's some.
obviously
Yeah,
the results or the benefits
yeah,
would obviously
yeah.
go there.
But I think if the government of Ghana, I know that there's a national research fund being discussed. I don't know the level it's gotten to. There's a bill on that. They're trying to look at that. But if such a thing should come in place, right, and the
Yeah.
government is supporting researchers, innovators, and all that, right, with some form of grant, right, I think that you'll be seeing more of such stuff coming up. And I also hope that the private sector, right, yes, would open up and work with academia, right, so that some of the innovations that come out of our academic institutions, right,
Mm-hmm.
we can actually, like, as in, roll them out easily. You get it? Yes.
Yeah.
But most of these things, they end up in papers, they end up being implemented in some donor country, and that is all. Ghana really do not benefit much. So with the research fund coming, right, I'm hoping it comes, right. So with the research fund coming, I think that you'll be seeing more of these local or research that impacts our local economy and all that, right. So that's what I think.
Yeah, I mean, when you think of this, what comes to mind is a country like Kenya, and you realize that Kenya is bringing up so much innovation in the tech industry because
Mhm.
they have I think, locally generated funds. Like they're actually pushing for a lot of these innovations, and realize that a lot of Kenyans are innovating and building. They are doing a lot of 3D printing. They are building windmills to produce,
Yeah,
electricity,
yeah,
in villages and all that. They are doing so much of innovation in Kenya, and I believe, Ghanaians are equally talented to be able to do same. But
yeah,
like you're saying, the funding is not available, so it becomes really, really difficult to actually push. Because yeah, of course, R&D is heavily, reliant on money that's available. So I think that, like you said, once the funds are available, the innovation would be able to thrive, right?
yes. And
Hmm.
I think, Joe,
Yeah.
during this COVID period, right?
Mm-hmm.
I know you've seen a number of innovations coming out of Ghana.
Yes.
Other countries, I don't want to talk about other countries, but let's focus on Ghana. Right?
Mm-hmm.
I think that these people uh, innovating, right? They are pushing all their funds in there because they know that if they push funds in there, gets some prototype, and it gets out there, the government might see and support.
Yeah.
You get it? That's why you're seeing a lot of innovations coming up, during this period. You get it, right? So it's let's hope and pray, right, that the thoughts that they are having, right, the government would actually see and provide some support in terms of funding, right, to help push some of these stuff. Because
Nice.
once you motivate people, right, you begin
Mm-hmm.
to see more of these things. Yes, and I think the president, the president is advocating for more local content and these is it one district, one factory, and all those stuff, right? These are the things that we need. So they need to support us, the innovators, the researchers. They need to support us so that we can feed into this one district, one factory agenda
Yeah.
that we have. Yeah. So that's that.
Yeah. I hope this video gets to them and they get to hear and they listen to our cry and our heed, or heed to our cry. Yeah. So it's interesting we are talking on this topic, right? Because I know my good friend of mine, George Apia, who is part of the Ghana Tech Lab. So they did a hackathon a couple of weeks ago to solicit for ideas and projects to help fight COVID-19. And
Okay.
so not only in tech, but then medicine and all that. And one of the people that went through that program, so they had available to them up to 10,000 US dollars to develop their project. And one of them that we've gotten to know is forgotten his name, but he's called Loud or Lord.
Yeah,
And
Lord, Incas. Yeah,
Lord,
Incas.
yes, yeah. So they collaborated with KNUST as well, right?
Yeah.
Yeah, so they are able to produce some testing kits that are very affordable. I don't know how much it costs though, but it's able to give a rapid result, I believe. Henry, you can correct me if I'm wrong.
Yeah, they are still validating it. So,
Okay.
but now it's not on the market. It's not on the
Sure,
market.
sure, yeah.
Yeah.
But I mean that those are some of the things. But even the Ghana Tech Lab, it's funded. I think it's funded locally, and also Mastercard. I
Yeah, but
think it's
to
funded
surprise
locally.
you, yeah. So most of the funding will be coming from Mastercard and all that.
Yeah, yeah.
I
Most will
know,
be.
I know. Josh does a lot of stuff with the World Bank and Mastercard and all that. Yeah. So those are some of the funding sources,
Yeah.
right? Yeah.
All right. We have some more questions coming in. We'll try to handle those questions in the next few minutes before we close. Um, let's see. Okay. So, front office again. Yes, so I understand front office is actually Sledge or
Oh,
Frimpong, right? Yeah, Sledge Frimpong.
yes.
So we now know the identity of the front office or who's at the front office. Yes. So Sledge is saying, hey, come on. Yeah, so in your opinion, and based on past experiences, do you believe the government will support this project? That's a question from Sledge
Hmm.
Frimpong.
Okay. So I think we are hopeful. We are hopeful.
Yeah, that's what Elliot Menka is also saying. He's watching from
We
YouTube. He
are
says
hopeful.
a bit more funding will be made available after this season. I'm hoping they fund the national HPC project as we want it. Yeah,
Mm.
so we have Sledge also says, I agree with you. Ghana has a lot of talent, and this should be the inception of innovation and enhancing of talent in the youth, especially the tech space. I should watch KNUST. That's an
Sure.
inspiring comment from Samuel Frempong, I believe watching from Canada or somewhere in the world. Yes. Yeah. So, last question, maybe if there's not any more questions, Victor Kumi is asking, how can we structure the educational system to be innovation focused? especially in our university. I believe this is a really, really important topic because
Yes, 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 yes.
you are a lecturer, Henry. You are a lecturer right now, and you are teaching the people right now. So
Mm. No,
what do you have to say about this?
I think Sledge will be able to answer this, eh?
How
Okay,
no?
but you see, I don't know, but now the student, if you try to help the students,
Hmm.
by integrating application, like giving them application questions, things that will make them think,
Yeah.
they tend to label you as a wicked person. Oh. And I have gotten my fair share of that. That one makes me. Yeah, but I think we need to take it from two sides, the
Okay.
side of the students and the side of the facilitators or the lectures, right?
Yeah.
So for on the side of the facilitators, I think now most of us we need to change our style of teaching, the way we do stuff, right? To
Okay.
more using the flipped classroom concept, where you don't go to teach,
Mm-hmm.
you go to facilitate, right? So using the project-based learning,
Approach.
right? The
Okay.
PBL approach, right? But if it will surprise you, right, you can give a project out to students. Mm. And now, because of student numbers and all that, you have to team them up, like put them in teams and all that,
Yeah.
right? You finish the course, and only the team leaders would know much about it. You might have a
I
talk.
think
You have a talk.
Henry, we've not been used to this system from childhood. So if you enter the university and from primary to SS and you enter university and you are now being thrown with applications, you would obviously struggle, right? I believe this system should start from the
Dr. Campos
grassroots, from the
basic
grassroots.
mech. I hope
Sorry,
you remember the Campos basic mech.
of course. I don't want to remember those. I mean, he was the worst of. I mean, the not the worst of my troubles in university. Um, those that did electrical would know PY, Ultra,
Oh yeah.
and what he
Oh no,
did to
but
a lot of us.
why is now the best, so don't worry.
Sorry?
The students that joined PY, he's
Oh,
now the best.
really?
Yes, yes, yes,
Oh, to this
yes.
day, to this day. Okay, well, I don't have nightmares about PY anymore, but I used to have nightmares about PY, Ultra. Anyway,
Like,
yeah. So I do believe that it should start from the grassroots, right? It shouldn't just be at the university level where students aren't used to it, right? Otherwise, students would basically just struggle with it because they're not used to it.
it's true, it's true. Because I think the students come in, they are geared towards or tuned towards passing of exam.
Yeah.
It will surprise you. You go to class the first day and someone is asking you, say what is coming in the exam. You said nothing. You are giving course outline. Someone is asking you, say what is coming in the exam. So you should know the kind of students you are dealing with. You
Yeah.
get it. Whatever approach you want to use to help them get the concept, no, that particular student is just waiting for how he or she is going to pass the exam. That's all.
Past questions and yeah, I mean
See that? You
we've
see?
all most of us have been through it and it's more
Mm,
tailored towards because more than 60% of the questions in the exam will be a past question, right? So
yeah,
of
yeah, yeah.
it's like a tried and tested way to succeed
Mm,
in the university in
mm,
Ghana.
yeah.
Um, yeah, but I mean that's the main difference between the education system in Ghana and in other places. And in Europe, like I'm currently doing a master's here, and it's mostly practical. Most like more than half of what you're doing is practical. And
It's centered on you.
yes,
You get
and
you do most of the research, most of the stuff, and the lecturer is
precisely,
just there to facilitate you.
yeah,
Okay,
yeah,
that's all.
yeah, precisely, and you know, uh, I'm doing artificial intelligence, and with machine learning, there is a lot of math involved, but they wouldn't bother you too much with how to do a partial derivative and all that. You need to understand, okay, why am I using this partial derivative? How can
Mm-hmm.
I combine this partial derivative with this other one? I mean, once you have that basic understanding of calculus, you have the understanding of matrices and how they multiply each other, how you can, do what a dot product is. You don't necessarily need to know how to calculate a dot product because the computer is now doing that for you. So you
Yeah.
need to know what a dot product means, what it can help you achieve, what can an integral help you achieve in engineering. But then, what do we see? A lot of the time it's like, oh, okay, this is the formula for, how to integrate this cosine, then, and then, and we don't know how exactly we are applying these, and so that's where I think a lot of people will be struggling, in terms of applying a lot of these theoretical concepts that we are taught in the university, right? Do you agree with that?
Oh yeah, yeah, yeah. It's true. It's true. It's true. Yes. But I don't want to be the one complaining. It's like I'm just complaining, just
Yeah,
complaining. Yeah, but the student number is huge.
yeah,
Just imagine. Yes. During our days, electrical, how many students were in electrical? Less than 90, right?
yeah.
Less
No,
than 90.
no,
But
we're about 103 in
no, it
my
was
time.
90. Oh,
I
no, you
remember
should
it
check.
was 103. Well, 90 and 103 is not so different. Yeah.
Okay, fine, 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 fine. Yeah, but now you have students in the 200s, 200 plus.
Really?
That is without free SHS. You get it?
200
So
students.
so so oh, serious. So how
Hmm.
are you going to handle a class like that? Even if you are doing PBL?
Yeah, the PBL that it requires you to be with the students and teach them,
Yes.
the
So you see, we
various
have we have we have we have so many
problems,
limitations,
right?
but yeah, but still we'll try to like just keep our heads up and see the best we can do to support our students. Yes, because your student is supposed to be a reflection of what you are. All right. So if you turn out students that are rusty, it means that you are rusty. So we are trying our best. Yes, we are trying our best with the limited resources.
Great, great, great. Yeah, so I think we have just crossed the hour mark. We should be coming to the end of this session. I think it's been very educative, very informative, very interesting conversation with you, Henry. And I'm sure those that have been watching on Facebook, on YouTube, on Periscope have enjoyed the conversation. You can continue to tweet about it, share um, how you enjoyed the session, right in the comment section. Or if you have any final questions, you can just put it in and we will try to handle it. But just put in the comment section, how you've enjoyed today's program. And you could probably thank Henry as well for joining us today. Let your comments flow. Yeah, so Henry, do you have what are your final comments, on everything that we've discussed today? Yeah, just leave your final comments then.
Okay, so I think we shouldn't kill the fire, right? We should keep the flame burning, the flame for innovation. Yes, we should keep it alive. Yes, because that's the future. If as a country we want to develop, that is what we have to do, and stick to local content. Yes, we'll get there. I think that's.
Wonderful. Let me give some shout outs to those that joined. So, Kweku Fosen, Yavin from Canada, I believe he is watching in YouTube. Elliot, thanks for joining in. Barry Smart, he's my colleague. He's in my class. he's watching all the way from Glasgow. No, he's not in Glasgow right now, but he's somewhere in Scotland. I don't know where. Ifwa, Joy, thank you for joining. We'll just take the last question from Ifwa. She's asking, I really like digital computer systems, but didn't choose it as an elective. Any advice for me? Do you have
Hmm.
any advice for her?
Hmm. No, I think it's passion, right? So even though you didn't take it or choose it as an elective to do, right? Yes, you have tons of materials online, right? You can get a project start. Once you get involved in a project, yes, find out what to do, how to go about obstacles and things that you face. It's passion because there are people who have never sat in, let's say, electronics class, right?
Yeah,
But have been able to do very wild embedded systems, put together very wild embedded
yeah,
systems.
yeah.
You
I
get it?
100% agree
Yeah.
with you.
So for IFWA, yes. So sorry you couldn't choose digital computer design or digital computer systems. Yes, but it doesn't mean that that's the end for you, right? Yes, the most important thing is the passion. Keep the passion alive. Yes, and there are tons of materials available for you, right?
Yeah, yeah, yeah.
That you can use
I
to.
100% agree with you. I mean, I'm doing software engineering as a profession. That's what's bringing money. That's what's feeding me. But I never actually did like a formal. I didn't do computer science. I didn't do engineering. I did electrical engineering, which of course there are a few courses here that are in common. But
Just
yeah, it just goes to say, and I know a lot of people that did, agric science, that did agric engineering, that did civil engineering, that are now in the um, IT or software engineering industry. So don't be. I mean, it's also an advantage, right? We in this industry, there's a whole lot of resources that you can find online. Udemy, what Khan Academy, maybe what's Udacity, YouTube, so many
Coursera.
resources. Coursera, yeah, you can find a lot of resources online to drive your passion. Yeah, it doesn't really have to be the course that you did in the university. I'm sure a lot of us, are doing other things than what we actually studied in school. So don't let that kill your passion. Ifwa, you can still pursue your interest in digital computer systems. The resources are there, trust me, and probably you might need some help, some mentoring from somebody who's already in the field. But I believe you can, with the resources, you can follow your passion. Yeah. Yeah, so I think, yeah, we're drawing to the end of yeah, Barry Smart is actually saying the best software engineers he's worked with didn't do computer science as a degree. And it's true. I think it's really true. It's really true. A lot of those that are actually doing a lot. Yeah,
Mm-hmm.
no, I think that, yeah, if you don't have it doesn't really matter the degree you did. If you don't have the passion in what you are doing, you
Yeah, it
wouldn't be able
becomes
to succeed. Yes, it becomes difficult. And once you have the passion, you can basically do anything that you'd want to do.
sure.
Yes. So don't let that discourage you, anyone. Yeah. Barry Smart is also saying he did engineering, physics, math, but he's now studying AI currently. So don't let your, especially if it's a first degree, first degree is just a starting point. That's what my mom always tells me. First degree is just a starting point because she's a professor. She always says that undergrad is just a starting point, and people have done two, and like they've done undergrad for 4 years and done another bachelor's for another 4 years. You can specialize in your masters, you can specialize in your PhD. So yeah, if I joy, we can talk more about it. I will do well to drop Henry's social media so that if you want to contact him for more questions or I'll drop Henry's LinkedIn and all his social media accounts in the description on YouTube. Um, on Facebook, you can just go to Tech Confab with Joe Budu. on Facebook and all our social media channels on YouTube. You can check on Facebook. You can check on Twitter. We are everywhere. Any way to get in touch with me, I'll drop my handles as well. You can find me. My handle is Joe B J0EBEE on almost all the social media channels. You can just search for me, or you can search for Joe Budu on Google, and you find me. And I would also put my social media links on the description. So thanks, Henry, so much for joining us today. It's been very enlightening. It's been a wonderful time. Thanks all my viewers watching from Facebook, YouTube, Periscope, and everywhere. Maybe you're watching from a pop-up in WhatsApp. Thank you for joining. And thank you for joining us as well, Henry.
And
And
thanks for having me.
we'll talk some more. All
Sure.
right.
Sure.
Goodbye.
Okay. Bye.
Uh, All right, guys. So it's been a wonderful time. Thanks everyone for joining. Don't forget to subscribe to get notifications on anytime that I stream. You can also follow on Facebook. Just search for Tech Confab with Joe Budu. You can find me on Instagram as well, Tech Confab with Joe Budu. You can find this podcast also on Periscope, Tech Confab. Just search Tech Confab and you'll find this podcast. I'll be streaming every Wednesday at 7 p.m. GMT. So yeah, Tech Confab, just join the stream. I'll be having conversations with other tech experts in the field. Just dropping your comments. How did you enjoy the stream and all that? And I'd like to see all the comments from everybody that came. Just let me know if you didn't comment earlier. Let me know who was on the stream today. Just comment your name and where you're watching from. If I haven't seen your comment, I'd like to know who is watching me tonight or this evening, and probably give you a shout out. Don't forget to like the video. Don't forget to share as well. Don't forget to like also on Facebook, everywhere. And yeah, so this is the first time I'm streaming on Facebook, YouTube, and Periscope. Just let me know how it went. How's the stream? Were there breakages? All that. Just let me know. And I will catch you guys next week, same time, same place. Thanks so much for joining. My name is Joe Budu, and this is the Tech Confab podcast. Goodbye.